Today in this lesson, I will derive the formula of energy of an electron. So first of all, we will focus on the simplest atom, that is the atom of hydrogen, which composed of one proton and one electron. If you do remember the derivation of the radius, so in an atom, two forces are there. One force due to attraction of proton and electron, that is called the electrostatic force, and the second force due to that force, basically, so electron revolve around the nucleus with the centripetal force. So right now in this derivation, I will derive the formula of energy. So first we will write the formula of total energy. E total equals to E kinetic energy and E potential energy. So first we need the formula of kinetic energy and the potential energy. So first I will make this equation as equation A, and now for kinetic energy, so I will use the same relation, that as we know that centripetal force is equal to electrostatic force according to this condition. So centripetal force have a formula mv square upon r equals to kze square upon r square. So the first simplification will happen between the denominator r. Now you can see this r can be cancelled by that r. Now after this cancellation, mv square will equals to kz square upon r. Okay, now if you just focus on this mv square, if we just put 1 upon 2 half here, so it will becomes equal to k. So for that, multiplying both side by 1 upon 2. Here we are not breaking any maths rule, so we are applying the half on the both sides, so we can do this. Okay, now you can see 1 upon 2 mv square. Basically this will represent now ke, and will equal to half k z square upon r. Now this is the formula of k. Now we will move uh, for the formula of pe. Now for the formula of pe, we will apply the formula of work, force into displacement. So for here, now just focus on the simple diagram. Now electron is right now in a position of the first shell. Let's suppose if we just move a bit in the transition of dr, or only a simple transition, so how much work it will done. So if we able to calculate this, so then we will able to know what will be the potential energy. Okay, now we know that the force is basically kze square upon r into, and displacement is dr. Okay, now this is the work. If we just integrate this by the integration, then we are able to get the final formula. Okay, right now I will not go in the detail of the how the integration will happen. Just quickly and shortly just remember that it will becomes p formula. After the integration, it will become minus kze square upon r. Now this is the formula of pe after the integration. Now uh, putting ke and pe in equation A. So we got KEP, so we will put in, so E equals to half K Z square upon R. Now here you can see the plus sign is there, but in the P formula we have a minus sign, so this plus sign will change and it will change into minus sign. So it will be written as minus kze square upon r. Okay, now if you just focus on this expression, this is half kze square upon r, and this one is only kze square upon r. It means it is 1 basically. This one is the 1. Half minus 1 means minus half. So E will be equals to minus half kze square. Now this is the formula for energy. Okay, now I will just give this formula as B, or you can say equation of B. Now here I will just put another expression of R radius. If you do remember, according to Bohr radius of atom, R is equal to n square h square into upon 4 pi square m k z square. So what I will do, I will just put this formula in the above equation. Okay, first I will make a simple change in this equation B before putting in B. So let me write it. E equals to minus half k z square, and right now what I did, I just change, I have written the divide sign here, divide into r. So it will make us uh, easier to understand how simplification will done. Okay, how, let me show you. So we can write E equals to minus half kz square divided by n square h square 4 pi square m kz square. Basically I just, what I did, I just put the value of r. Okay, if you do remember, when this, for the simplification, we change this sign, divide sign, into multiply sign. If we change this divide sign into multiply sign, after this the fraction get altered, so denominator replaces numerator. So let me show you how. It will become minus half kz square into 4 pi square m kz square upon n square h square. Now here we will try to simplify as much it is possible. Only the 2 is, this 2 can be cancelled by this 4. 2 ones are 2, 2 to the 4, and after that the upper part will be multiplied by this kz square. So after this, what, how can we write? E equals to 2 pi square m k square z square e power 4. The reason is that there is e power 2, and here is also e power 2. It will become e power 4, and z will have power 2, k will have power 2. So we should be very careful about this power. Okay, in the denominator side we will have n square h square. Now this is the complete drive formula of energy. So now what we will do, we will just separate from this formula all the constant. Let me show you how. This is the formula of energy, so I can just change this formula in this way. E equals to minus, sorry, 1 upon n square into minus 2 pi square m k square z square e 4 upon s square. Okay, in this bracket all the values are constant, only this n is not constant, it is variable. Basically it represents the shell number. So if we just put all the values of the constant, let me show you how. Here the mass is equal to 9.11 exponent minus 31 kg, and k is the coulomb's constant, it value is 9 exponent 9, and e is the charge on electron, that is 1.6 exponent minus 19 coulomb, and this one is the charge of proton 2. Okay, here the value of h, that is called Planck's constant, it is 6.63 exponent minus 34 joules second. Okay, right now I'm using all the values which are basically in SI unit. So we will be getting the formula of energy in joule after putting all the value. Okay, what value I left? Yes, z. Z will be 1 for hydrogen. Okay, so let me put all these values. After putting all this value, E will equals to minus 2.178 exponent minus 18. Okay, here now you can see I have put all the values, and you can do the calculation with the help of scientific calculator directly. So you will able to get this value minus 2.178 exponent minus 18. Okay, here I just the thing left, that is 1 upon n square. Okay, now this is the final and the most simplified formula of energy in term of joule. So we have sometime another thing that let convert this joule into kilojoule per mole, because the kilojoule per mole is the most common formula. So how we will just convert this joule into kilojoule per mole? So there is the only simple way, that if I just take this value of minus 2.178 exponent minus 18, basically this value represent only one atom of hydrogen. So when we talk about the 1 mole of atom, so in 1 mole we know that there is a huge value that is called Avogadro's number. So if I just multiply this number by Avogadro number, so it will convert into per mole, and if I just divide this value by 1000, so it will totally convert into kilojoule per mole. So I will do just simple multiply by Avogadro number and divide by 1000. So after this calculation, the whole value will become kilojoule per mole. Okay, now you can do this calculation with the help of scientific error directly. So the value we will get at it will be E is equal to minus 1313.315 approximately, and the unit will be kilojoule per mole. Okay, now remember that this formula is for general formula basically, because right now we haven't mentioned any shell number. So if you want to mention any shell number, let's suppose for energy, the energy of electron in the shell, the first shell, so what we will do, we will put n equal to 1. Even will equals to 1 upon 1 square into this value minus 1313.315. So the energy of the first shell electron will be minus 1313.315. So similarly, if you want to calculate the energy of the second shell electron, so you will put n equals to E2 will equals to 1 upon 2 square. Basically here in place of n we will put 2. So after the calculation in the similar way we will get minus 328.328 kilojoule per mole. Additionally, another thing here, we can also convert this joule into electron volt. This is also very common. So now how we can convert this joule into electron volt? So this one is also have a very simple method. So this is the formula. Basically, the value of minus 2.178 exponent minus 18, if I just multiply this value by one single value, that is 1.6 exponent minus 19. Okay, what kind of value is this? Basically this value is a charge on electron. If you do remember, 1.6 exponent minus 19 is the charge on electron or proton also. So if I just divide the value of joule with charge on electron, then this joule will convert into electron volt. So in electron volt, the value is minus 13.6 and the unit will be electron volt. Okay, now in the similar way, we can now calculate the energy of first shell electron, second shell electron in electron volt by putting the value of n's. So for first generation n will be 1, so it will becomes 1 upon 1 square into minus 13.6 electron volt, so it will be minus 13.6 electron volt. Similarly, for the second shell electron, n will be equal to 2. So E2 will be 1 upon 2 square into minus 13.6 electron volt. And after the calculation, the value will be minus 3.40 electron volt. Okay, even you can put any shell number and you can get the value of energy in electron volt. Okay, remember that all the values will come in negative. The reason is very simple, because in our formula we have the negative sign. So that's all. Thank you.